Hi everyone. Today I'm going to show you a strategy to improve your SQL-based business transformations in Snowflake and, in the process, achieve a significant drop in processing times. As we all know, one of the most expensive operations in databases is also the one you can't do without, database I/O. What would a database be if it couldn't read and write data? But in my experience, the way in which business transformations are written often results in a lot of unnecessary I/O. And it is this unnecessary I/O that slows down the transformations. In this short video, I'll show you an example of a pattern I see all too frequently that contains unnecessary I/O, and then an example of how these transformations could be rewritten to reduce this I/O penalty. My name is Malcolm Green, and I'm a Senior Data Engineer Data Architect at Projective Group, a boutique consultancy specializing in all things data. I've been working with databases for over 25 years, covering Oracle, SQL Server, Netezza, and now Snowflake, and I'm passionate about helping people squeeze that last drop of performance out of their databases. That's enough intro, let's see some code. So what I've done in my Snowflake account is set up what I think is a pretty standard data warehouse configuration. I have a presentation layer that holds my facts and dimensions. In this instance, I've got a fact table for orders and a customer dimension. I have a raw schema that is used to hold all the data that's ingested from source systems. And I have a transform schema that is used to hold all of my business rules, my transformations, whether they be database views or stored procedures. In this particular scenario, the business have come to us and said they've got 3 business requirements they wish us to code. So for those customers who place an order in a specified year, they want to update the customer dimension with the total spend to date and the date of the last order. For those same set of customers, they also want to update the dimension with the values from source. And finally, for those same set of customers, update the customer status field in the customer dimension using some supplied logic. Now, I've taken those 3 business rules and written them into 3 independent procedures. The first procedure is what I call the I/O intensive one, and then 2 additional examples where I've reduced the I/O. So let's get those running in the background, and then I will take you through the packages. So this first procedure is the I/O intensive one. And what you can see here is the developers decided, because all of the rules need to work on the customers that have made an order in the year that's provided to the procedure, they're going to have a customer table, like a temporary table, and they're going to select all the customers from the customer dimension that have made an order in the year. And that's that query there. Once they have those customers, the first requirement was to update the customer dimension with a total spend to date. So I've written a query that joins the fact table orders to the transform customer. So that's my temporary table. And I've aggregated up the total sales and got the maximum order date for that year. And I merged that into my temporary transform.customer table. The second requirement is to update the customer dimension with the values from source. So this is a simple merge statement, taking data from raw.customer, so source system data, merging on the customer key, and just updating all the fields. And then the third requirement is where I'm updating the customer status. So the customer status is written in a case statement. So if a market segment is machinery or household, based on the total sales, I set it to bronze, silver, or gold. And if it's not machinery or household, to anything else, I've got the else part, and again, bronze, silver, or gold, but I've just changed the amount of total sales that need to go into those brackets. And of course, once that has updated, I can then merge the results back into the presentation customer dimension. So hopefully they will have finished, and they have. So let's just have a look. I've got written a query here that goes against the information schema query history by session, just to have a look at what's happening here. So let's get rid of that side panel there. So what you can see is run number 1, which was the I/O intensive one. It processed 4.3 million records. It scanned over a gigabyte of data, and it took 30 seconds, 29.32 seconds. My second run, where I've rewritten the transformations to reduce the I/O, actually only read 794 megabytes. So it's a 27% decrease in the amount of bytes it scanned. And it ran in 13.5 seconds, which is a 53% decrease in time. And then my third run, which is a slight rewrite that I'll show you, have managed to get the IO down to 470 megabytes. And in this instance, it's a 50-60% decrease in IO. And again, that ran even faster, 12.29 seconds, which is a 58% drop in time. Now, this last one is slightly strange because it's variable. Sometimes it runs fractionally slower than the second one, and sometimes, like in this case, it's run slightly faster. You can see here's quite a considerable drop in IO for not a drop in time that's significant. We'll talk about that later. So let's go and have a look at run 2 and find out what I've done. So effectively, when looking at the code, I realized that we were using the same set of tables multiple times. So what I've done is I've rewritten the query into one query. So what you can see here is I'm going to my customer table, the raw customer. So that's the customers that have been ingested in from source. I'm joining it to my orders table. I'm only selecting those orders that are less than or equal to the current year. I'm aggregating up the total sales, which is requirement number 1, and getting the maximum last order date, again from requirement number 1. And then let's get in the fields from the raw.customer dimension, so that's requirement 2, so I'm getting all those fields. And then requirement 3, there's my case statement. I'm using a nice feature of Snowflake where if you've defined a field higher up in the query, so total sales is the sum, I can now reference that field in my case statement. And then I'm only interested in customers actually made an order in the year. So I've also got an additional filter here, selecting only those customers, again, going back to the fact table. So, and then obviously it's standard merge, and I merged that in. And if I go back here, we'll see, yeah, 794 megabytes and 13 seconds, which is a 53% drop in time. Now, as I mentioned, my third one had the lowest IO. So what did I do there? So I realized that when I was running this merge statement, because I had this filter here, I had another read of my fact table. So I thought, actually, maybe I can get rid of that. And actually, because I was already calculating the maximum date for the maximum order date, I can actually just replace that with a having clause that says having the max date is equal to the year that's passed into the procedure. Now, yes, in this instance, it runs slightly faster. You have to be careful here because the balance between reducing the IO, but then obviously the having clause is going to take more CPU. So in some instances, this did run slower. But as you saw in this case, it did run slightly faster, but again, reduced the IO even more. So if you find you have a procedure that utilizes the same set of tables or views multiple times, have a think about rewriting it to use fewer DML statements and thus reduce your IO cost. You might be surprised at the results, proving that not all SQL is equal. This is the first of what we hope will be many short videos based around the theme of not all SQL is equal. We aim to show you the good, the bad, and the ugly in the world of data engineering, along with demonstrations of new and exciting technologies, predominantly around the Snowflake database, although many of the techniques are just as relevant to other database systems. Thanks for watching. Please let us know your thoughts in the comments below, and don't forget to subscribe to be notified of future videos in the series. Bye for now.